Hi guys, welcome back. For those of you who may be new, my name is Michelle. I have been a math tutor in New York City for almost 10 years now. Went to school for math education, so definitely passionate about teaching. And I'm actually headed to Columbia Business School in the fall. So I have just gone through my own test prep process, and I feel for you. I know what it's like to be in your shoes. It's stressful. There's a lot of material to cover. So hopefully my videos can be helpful in your preparation. Please comment down below what topics you want me to review for you guys. It'll be helpful for me to know what you guys are struggling with. And subscribe so you know when every time I come out with a new video. It should be almost weekly at this point. Okay, and so today we're going to be talking about the 5 must-know formulas for the SAT and how to use them. So the thing with formulas and memorizing formulas is it is important, but a lot of the times the way that the test actually requires you to use the formula is not intuitive or not obvious. So we're going to talk through some of the important formulas that you should be comfortable with and how to actually spot when to use them, what types of questions will ask you to use the formulas. How do you know? How do you know how to apply them, right? So let's jump right in. My first formula for today is the difference of perfect squares. And this is a really important formula. A lot of the times it's hidden on the exam. It may not be obvious. And basically it's a very simple one to get right. And I want your brain to sort of be triggered right away when you see certain numbers. So the trigger here is 2 perfect squares and subtraction in between them. So what's a perfect square, just to quickly review? Any number that is being multiplied by itself twice is a perfect square. What do I mean by that? Simply 3 times 3 is 9, so 9 is a perfect square. 4 times 4 is 16, so 16 is a perfect square. X, a variable, x times x is x squared, so x squared is a perfect square. So that's how you kind of know whether you have perfect squares or not. And of course, they get trickier and trickier once you get to more challenging problems. But at a very basic level, it's not too complicated. You can basically rewrite x squared minus 9 in a different way that may help you solve certain problems or may help you see something on the exam. So x squared minus 9, of course, x squared is a perfect square. And how do I take the square root of that? Well, it's just x squared becomes x. 9 becomes 3, and we just do different signs in between them. And of course, if you FOIL this out, you'll be brought back to x squared minus 9. The one below is a little bit more challenging, maybe one more step challenging because of this 4 here, but same thing, take the square root, right? So 4x squared, the square root of that is just 2x minus 10, 2x plus 10. And don't forget that these signs have to be different in order for this to work, in order for this to FOIL out. And basically the generic formula for this is really x squared minus y squared. That's the form. Anytime you see this, you can rewrite it as x plus y, x minus y. Simple enough. Let's see how you actually are tested, how the formula is actually tested on the exam. So if t is greater than 0 and t squared minus 4 is equal to 0, what is the value of t? Okay, I always tell my students, first things first, what am I finding? I'm going to rewrite. So in the corner of my page, I know that I'm looking for t. T squared minus 4 is my equation, so I'm going to rewrite that. And then I'm given this weird fact in the beginning, and I'm going to keep that in mind. You're never given extra information than you need. So anytime you're given any clues in the question, make sure you're taking note of that, because you're going to use that information in some way. And if you don't use that information in some way, you probably did something wrong. So that's a really good clue. Okay, again, as soon as I see this, and because we just reviewed it, it might be obvious to you, this is a classic difference of perfect squares, right? This becomes t squared minus 4. It could be rewritten as t minus 2, t plus 2, setting both equal to 0. Of course, now we just set each side equal to 0. Add 2 on both sides here. So I get t is equal to 2 as one of my answers, but because this is a quadratic, we get 2 answers, right? So t, I'm going to subtract 2 from both sides. I get t is equal to negative 2. So now what's my answer, right? Now I have 2 answers. I guarantee you choice A will be something like 2 and choice B will be negative 2. And so which one do you pick? This is where you use that information at the beginning where it says t has to be greater than 0. That information is telling you which of these two you should eliminate. Which number you should be eliminating. Well, t has to be bigger than 0, then it has to be this one, right? Because negative 2 is less than 0. And so 2 becomes your answer. Okay, next one, average. You've probably learned averages when you were in middle school. The test likes to test these because a lot of the times they'll give you big numbers to add together, and there's a different way that I'm going to show you to kind of use averages to your advantage and solve them quickly on the exam without having to sum a lot of numbers. But on a very general sense, your average is the sum of all the items that you're looking to take the average of divided by the number of items you have. The only thing I will say here is that whenever you have averages, and let's say you're talking about, oh, I want to get a 90 average in a class. If you were to get a 90 on every single thing that you're graded on, then you will get the 90 average, right? But a lot of the times you'll get a little bit higher, a little bit lower. And so understanding that an average is really like taking all those numbers and finding that middle ground. But if you assume all of your tests are that 90, that's a very helpful way to think about averages. So let's walk through a problem and kind of talk about what I mean here. So Michelle scored a 78, a 77, and 82 on the first 3 math exams. Great. If she wants to get an 80 average, what is the least she can score on her 4th test? So the first thing I want to notice is I want this 80 average, right? And then I'm looking at my numbers and I got lower than an 80, lower than an 80, slightly higher than an 80. So my guess is going to be that I need slightly higher than an 80 to offset the two numbers that are lower than an 80. And using that information, if I, again, I'm thinking to myself, if I wanted the 80 average and if I was a perfect student, I would have gotten 80, 80, 80, 80. But I didn't. I got a 78, a 77, 82, slightly off, right? So how much am I off? This is how I can actually calculate what that last score should be. Well, here I was 2 under, right? I was 2 points shy of the 80. Here I was 3 points shy of the 80. And then my positive here, I got +2, right? So I was off by -2, off by -3, but then I gained back that +2. So these two numbers actually end up canceling each other out. With these two numbers, I already averaged the 80. So that means these two numbers, my two final numbers, 77 and whatever my new number, they have to average to 80. Well, this one is -3. This is short 3. So that means this one has to be 3 more than what I'm looking for, the 3 plus 80, right? And even if you're looking at your answer choices, you know that it can't be 80 because what? That wouldn't be enough, right? I already scored too low here for my last number to be an 80, right? So that you can use process of elimination to help you there as well. So that's kind of called spreading the butter, I like to call this. It's like taking the number that I want and seeing how far I am away from that number and spreading it out to that last number. 3, this one is a lot of formulas, obviously, not just one, but it's basically everything that you need to know with slopes and graphs and coordinate geometry. So of course you have to know what is the slope formula. I remember this as just change of y over change of x. That's kind of what this triangle stands for. I'm basically taking the difference between the 2 y coordinates and taking the difference between the 2 x coordinates. The one thing I will say here that people kind of mix up a lot of the times because you're rushing on the exam or you're nervous is which coordinate I'm starting with. If I'm given 2 coordinates, A and B, and both have, I don't know, let's just say this one, these coordinates are AB, these coordinates are CD. If I'm doing my change of y over change of x to find my slope, and I'm starting with my B coordinate, so I'm starting with that D minus, then I'm going to subtract the B, well, then I also have to go back to the B and do C minus A and not switch up your coordinates, right? So if you're starting with your B coordinates first as these numbers, make sure you do that for the denominator as well. Equation for a line, what do I have to say here? Nothing too crazy except knowing that your standard equation of a line is y equals mx plus b, and knowing that what each of these coefficients stand for. So m is your slope, right? The number next to the x is your slope, and b is your y-intercept. I'm going to do a whole video on coordinate geometry, so if any of these feel sticky and you're not comfortable with them, definitely check back and you check out the video on coordinate geometry. Midpoint formula, this one's easy to remember, and a lot of people get intimidated because it looks like a lot of numbers, but you're basically just taking the average of your x coordinates and of your y coordinates. So your midpoint formula is actually giving you the midpoint coordinates, right? That's the thing to remember. That's why you have the comma and the parentheses here, right? So this will end up being a number, and this will end up being a number. And it's just the average, x1 plus x2 over 2. You're given 2 points, and you're trying to find the middle. So of course I'm finding the average of my x coordinate to find that middle x coordinate, and the average of the y coordinate to find the middle of the y coordinate. So again, just think average, midpoint, average for that one. Distance formula, unfortunately, this is one that I have just memorized year after year. It's an annoying one. It's the difference between the x squared plus the difference of the y squared, all under a square root. It's a messy one. It's one that you just need to become comfortable with using. Okay, let's check out one coordinate geometry question from the SAT. So this one is, what is the slope of 4y plus 3x is equal to 12? What is the slope is what I'm looking for. Cool. And I'm given an equation of line, but it doesn't look like the equation that I'm comfortable with. So the one that I'm comfortable with is y equals mx plus b, where m is going to be the slope I'm looking for, and this b is my y-intercept, right? That number at the end. So great. If you know this, now I see all I have to do is rewrite this equation to look like this, and I'll get my m, right? The m is what I'm looking for. Always write that to yourself. Like, what am I looking for? Because a lot of times you'll do all the solving and then you won't answer the question. So I'm going to rewrite my equation. And I'm going to say, okay, I want to isolate y, right? So how do I isolate y here? I'm going to subtract both sides by negative 3x, right? So I'm going to get negative 3x plus 12. And then I'm going to say, okay, I want to get the y by itself. It's attached to this 4. I'm going to divide out by 4. This cancels out, and I get y is equal. Here's the tricky thing. And so many students, it drives me nuts. So many students forget this part. And if you're nervous, it's not a hard thing to forget. But after this lesson, I hope that no one here makes this mistake. You have to divide both terms by 4. Don't forget to divide the 12 by 4, which a lot of people do. What do I mean by that? This answer is going to be negative 3 over 4x plus 12 over 4. Do you see how that 4 goes to both terms? You cannot forget that. And of course, when I simplify, I just get this, right? And so what did I find? I found the equation of my line, but I'm really just looking for the slope. So the slope in this case is negative 3 over 4. All right, sides of a triangle. So this is one of those facts that not everyone knows, but as soon as you know it, it'll help you with certain problems, and it's a great one to know. So the sum of any 2 sides of a triangle must be greater than your third side. What does that mean? Well, basically, if you're given 3 sides, A, B, C, and I was looking at what are my possible values for C? Well, C always has to be less than the sum of the other 2 sides. So if my other 2 sides are A and B, then I know that C must be less than A plus B. So how do I use this in a problem? Okay, the lengths of 2 sides of a triangle are 5 and 9. What is the greatest possible integer length of the third side? So I'm going to draw out a triangle for myself. I always find it easier. I'm like, okay, 5 and 9. I don't know the third side. And I'm looking for what is the greatest possible value or integer length. Integer is a helpful number there, or a fact there, right? It has to be an integer, or basically a whole number. So what is the greatest possible integer length of the third side? Well, I know that the third side needs to be less than the sum of the other 2. So x has to be less than 5 plus 9. X has to be less than 14. What integer is the greatest integer under 14? 13. So this problem, if you didn't know that fact, I would have a hard time trying to visualize what that third side is. But as soon as you know that there's this theorem out there, this problem becomes a breeze and something that you can save a lot of time on without having to think too much. The last thing I want to go over is rates. So of course, I'm sure you're familiar with distance equals rate times time. Average speed is where the test gets a lot of people. And I think a lot of the times it's the difference between an okay score and a great score. So average speed is found by total distance over total time. That's all you need to remember. total distance over total time is my average speed. Don't ever get into this mentality where you're like, oh, well, you know, if I'm gonna go this distance, then maybe my average will be this. Just remember, average speed is total distance over total time. I swear to you, if you write that on your paper when you see the word average speed, you will not go wrong, because it is a little complex in terms of what it actually means. So let's do an example. A car traveled 10 miles at an average speed of 30 miles per hour, and then traveled the next 10 miles at an average speed of 50 miles per hour. What was the average speed in miles per hour of the car for the 20 miles? Whenever I do rate problems, I draw them out for myself so that I can really visualize what I'm doing here. So it looks like I'm traveling 20 miles. And this is standard for all average speed problems. You're going to be going a different speed for a different length of time. So in this case, I'm traveling my first 10 miles at 30 miles per hour. So I'm actually halfway. And so this whole stretch I'm going to do at 30 miles per hour. Then the next stretch, the next 10 miles, I do faster. So maybe there was traffic to begin with and the traffic lightened up. So now it's 50 miles per hour. Again, go back to your formula. Average speed, right, is equal to total distance over total time. In this case, total distance is very easy. It's 20 miles, right? Total time is where this gets a little confusing, but it's not difficult. So follow along very closely and you'll get every problem that you're asked for average speed here. So total time, I don't have time anywhere in this problem. I have to figure it out. And the clue is your time is going to be different for both intervals. The time it takes me here is going to be different than the time it takes me here, and I just have to find the sum of the two times. So how do I find that the first interval time? Well, I'm going to go back to distance equals rate times time. I know the distance of the first interval is 10 miles. I know the rate that I'm traveling for that first interval is 30 miles per hour, and I'm looking for the time. I'm looking for that t. So I'm going to isolate t by dividing by 30, and I get t is equal to 1/3. That basically means that that first interval I traveled at 1/3 of an hour. So I'm just going to write 1/3. Now I have to find what was my time for that second interval, right? So, okay, same thing, distance equals rate times time. And I get, okay, my distance was still 10 for that second half. My rate is now 50 and time is what I'm looking for. Divide out by 50 and my time is equal to 1/5. So now I'm gonna erase what I have on my paper. Now all I'm doing is saying, okay, I have to simplify this and I get my average speed. So let's do that together. It's a little bit mathy. So I'm gonna give myself some more room here. I'm gonna erase this. I'm gonna zoom, hopefully zoom. This is gonna cooperate with me. It's okay, if it doesn't, it's fine. Let's keep going. So 20 over 1/3 plus 1/5. How do I do that? Well, I have to get a common denominator in that denominator. So I'm going to multiply that first fraction by 5, second fraction by 3. And I get 20 over 5 plus 3 over 15. Then I'm going to do 20 over 1. Well, this is really going to be 8 over 15, right? So 20 over 1, keep change, flip. I'm going to flip that bottom fraction. And then I'm going to simplify. Divide by 4, 2, divide by 4, 5. 5 times 15 is 75 over 2, which is about, what, 37.5. And that's my average speed. So my average speed is actually 37.5. And the important thing to remember here is a lot of people will think the average here is 40 because you're going 30 miles and then 50 miles, so that middle number is 40. But actually it's 37.5. And I guarantee you always on these problems, one of your answer choices will be the standard 40. Like I always call it the dummy answer. It's the answer that most people will pick if they haven't studied enough. So hopefully this makes sense. If a little bit of my arithmetic, you feel like, oh, how did she skip that step? How did she simplify? I'm gonna do a separate video on how to do math more efficiently, more quickly, without making mistakes. And I'm also gonna do a video on how I kind of make sure I keep my paper neat. I think it's super important when you're rushing to make sure all of your numbers are clear, all of your math is clear, because I hate when some of my students like know how to do it, are nearly there, and then they mess up on the arithmetic. It's something I always struggled with and definitely want to help you guys out with. Okay, those were my 5 formulas that you need to be comfortable with. Hopefully that made sense to you. Like I said, please subscribe. We're going to be having new videos. Let's get through this together. And if you have any suggestions for videos, comment down below. I'll see you guys next time. Bye.